Okay, so you have your graphic organizer, or you have your graphic organizer on your screen and some paper. And what you're going to do is the first three problems on the graphic organizer. In a moment, I'm going to say press pause, and you'll do that. And I want you to try those problems. They're all problems we have done before. Doesn't make them easy, but they're problems we've done before. Once you're done, I want you to press play, and I'll show you the answers. Okay, and then we'll talk a little bit about algebra. So press pause and answer questions 1, 2, and 3 on your graphic organizer. Okay, I'm assuming you press pause and now you're back to see your answers. So the first problem, what we do is we graph our two lines, right? And you might have used a different method. What I did, because this is good. As the problems get harder, this is a method that's going to work more times than it won't, and it's gonna be a bit easier down the line. I know you might not believe me yet, but down the line this will be. So anyways, what I did was I took each equation and I solved for my intercepts. Okay, if you want to press pause and take a look at my work, feel free to. But ultimately, what I did was I found what y was when x equals 0 and what x was when y equals 0. And that gave me 2 points, and I graphed them. Question number 2 has us find the solution. And what the solution is with the system of equations is going to be the intersection point. Now, your intersection point might be slightly different than mine. That's human error or just human difference. I don't even know if I want to say error, but more just, the fact that we're graphing by hand makes them a little less accurate, right? So when I read my graph, I go over 1 and down about 4.5, and that's my intersection point. Okay, and even when I say about 4.5, we know that that's not going to be exact. It might be, but it might not. Question number 3 goes on to ask, how can we use algebra to confirm our answer? Okay, or get a more precise solution. So we could solve the system for the x and the y values that work for both equations. If we found the x value that works for both equations and the y value that works for both equations, we're going to find the solution to the system of equations using algebra. Turn your paper over and you're going to see an example. We're going to do one example together as an intro of this. Mine's a little less formal than yours. But there's my example, okay? This is an example of the elimination method, and you might have seen the elimination method in the past. Eliminate means to get rid of something, right? And so the problem with this system is that we have too many variables to deal with. We can only solve for x or we can solve for y. We can't solve for both of them at the same time right now. So what we have to do is we have to see, can we eliminate something? And what I notice is if I look at each of the like terms here and I add these two together, or all of these together, what I notice is something is going to eliminate. 2x plus x is 3x. Positive 3y minus 3y is 0y. And 15 plus 3 is going to be 18. And if I bring down all my signs, what I have now is an equation that eliminated. Nice. And so what I have left is I have the equation 3x equals 18. This is gold. I wanted just one variable, and now I have one. I'm going to divide both sides by 3, and I get x equals 6. Great, but remember, it's a point. A point has an x and a y value. So if I know x equals 6, I can take that answer, plug it in either of these equations, and it should work. I'm going to pick the first one. It doesn't really matter at all. So if I pick the first equation and I plug x equals 6 in, I get 2 times 6 plus 3y equals 15. Again, I like this because my only variable that I have to solve for is y. 2 times 6 is 12 minus 12. And 3y equals 3. Divide both sides by 3, and I get y equals 1. Awesome. There's my point. Just circling this or leaving this work as is and calling it a day is not going to be a solution. Instead, the answer or the solution to the system of equations is an x and a y value. And so in this case, it's going to be 6, 1. And what that means is, however these two equations graph, the point where they intersect is going to be 6, 1. My solution to the system of equations is 6, 1. This is accurate. This is exact. Again, assuming we did the math right, but let's make that assumption. Whereas if we did this by graphing, it might not look as exact, okay? So this is the elimination method. This is one form of a problem. What you're going to do next is you're going to make some notices and wonders about this. Look on Google Classroom, and we'll be talking about this in your next in-person days. Take care.